Good morning and welcome to the final day of this year's Calpe conference. Before I announce the first speaker and introduce the first speaker, I'm going to read the general housekeeping announcements and the rules that we have to abide by today. So due to the ongoing COVID-19 restrictions, face masks must be worn at all times inside the conference hall. Hand sanitizers have been provided. Social distancing, 2 meters minimum, should be observed throughout the rest of the university facilities. Please use a face mask where social distancing is not possible. The conference proceedings are being live streamed via the Calpe Conference YouTube channel. Links are available via the Gibraltar National Museum's Facebook and Twitter pages. Anyone watching remotely is encouraged to send in any questions they may have for the speakers via the live chat on YouTube or the museum's social media pages. You can also join the conversation online using the hashtag Calpe20 hashtag. For speakers, speakers may remove their masks if delivering their presentations while sitting at the speaker table. If you choose to deliver your presentation standing, you must wear a face mask. Please use the hand sanitizer provided before starting your presentation. Okay, so the first speaker this morning is Dr. Darren Farr, who is the Director of Academic Programs and Research at the University of Gibraltar. After obtaining his PhD in biological oceanography from the University of Southampton in 1998, he then moved to the Gibraltar National Museum in 1999 as Education and Research Officer, where he also read for a master's degree in museum studies from the University of Leicester. Darren.
Thank you very much, Alex, and good morning to all. Thank you for coming so early on a Saturday. Thanks also to Clive and Jerry for the invitation and to the university for a lovely venue. And I work here, so that's good. Okay, so I'm going to talk today about the relationship between humans and the sea, which is very broad. So what I thought is, after a lot of thinking and having to leave lots of stuff out, I thought I was going to see if I could meld parts of my own trajectory in this particular area and see what sort of insights, if any, and what lessons might have emerged. Okay. First lesson, technology always doesn't work. Okay, that was it, yep. So, there is, people have had a relationship with the sea in many, many different ways. It transcends aspects of culture, but it also transcends aspects of exploitation. We use the sea as an area where we get resources from, particularly food. In fact, the sea, it's quite safe to say, is the only remaining biome where, on a large scale, we hunt for our food every day. And the other one is as a medium of transport and facilitating the movement of people and goods around the world. This particular area is worthy of another entire talk, so I'm not going to dwell on it, but we can certainly talk about it if you wanted. And people like the sea. People like the sea. It gives them an opportunity to have leisure activities, etc. And there's, for many people, a spiritual sort of affirming dimension to the sea. But what we have at the moment, and this is based on obviously predicted data, but good data so far, is that within 3 decades, if trends continue, 75% of humanity, or about 6.4 billion people, will reside in coastal areas. And in fact, I mean, Tyson used an image of the Straits by night yesterday. This is a larger one of the world. The main reason that most of the continents can actually be seen clearly is because there's a lot of people living around the coast. And if they're living inland, it's because we have the technology to allow them to live inland. So, the many, many threats to the marine environment that the sort of infographic just illustrates some of them. And we know this. We're constantly, at least more and more recently, almost constantly being bombarded by the effects of these impacts, whether they're stemming from pollution or whether they're stemming from sort of exploitation or associated areas thereof, loss of ecosystem services, etc. Okay, so now a little bit about myself. So some of you, Geraldine will remember this because she was diving on me at the time, will know that I have done, I'm a marine biologist by profession really, but I have also have been lucky enough to also sort of participate in things like underwater archaeology, etc. And it was a really interesting melding of the two. And a lot of people also know that I've been interested for a long, long time in obviously in the marine sphere, particularly the intertidal. And it's actually, even though it doesn't appear to be at first sight, quite a dynamic and sensitive ecosystem. The real reason I ended up in the intertidal was, I mean, I love to dive, but it takes ages to get everything together. You need someone to go with you, and when you're actually holding a full-time job, then if you just nip down to the shore at low tide, someone's taken the water away for you, and you can actually go down and count your animals and do your stuff and come back, but still do some good research, I think, within that particular ecosystem. So to a large extent, it was convenience which then evolved into a passion. But as you will see later on, I think people tend to do a lot of things for convenience, and then that takes them down particular pathways that it's difficult for them to get out of later on. Not that you want to, but that happens. So, now, when I came back, and Alex just mentioned that when I did my PhD, I came back really pretty much a trained ecologist, subscribed to the mantra essentially that all environmental factors taken together with community interactions essentially defined what you were getting. They defined the species you got, they defined the ecosystems you got, and therefore if you could measure all those factors, interactions, etc., you'd be able to get an insight into what's determining that community size. You'd be able to answer questions. And even though the notion of historical contingency was often bandied around, the reality is that it wasn't something that was easily measured or looked at. So you'd either dive or you'd go to the shore. That's long time ago, one of my PhD students, who's now actually a professor at the University of Seville, but there we were sort of like making cages for limpets on the shoreline. And you try to control, well, you try and measure as much as you can. You measure your salinities, your temperatures, your insolations, you measure also by interactions between organisms, all of these things to try and answer questions. And you obviously, the reality is that in most cases, you do actually get a lot of very, very valuable insights. This stems from my original thesis. Those were the 20 points I was sampling at along the southern edge of the Iberian Peninsula. And it was very much an attempt to get an insight into what were the controlling variables that defined the changes in community structure along that particular sort of coastline. And the one thing that emerged, which is quite interesting because I'll come back to it later, as a really primary controlling factor was tidal amplitude, just the size of the tide, how big the tide was. And we'll come back to that afterwards. Now, linked to this, obviously, and I say this because a lot of people, you ask in Gibraltar, do you know about DARREN? Yeah, he does limpets. It's cool. I mean, it's not as sexy as dolphins, but and people say, why do you do limpets? I mean, well, maybe, again, it was one of those things that you almost fall into, but they are really quite interesting creatures. I'll just give you some quick biology. They're intertidal grazers. Dioecious, essentially, it means that they are all usually born one sex and then they become another, usually males and then they become females, but sometimes they flip-flop. They're quite interesting. They attach themselves very, very strongly to the shore, to the rock. They're practically impossible to prise off if they don't want to move. They've got gills, which means that so it means that when they're out of the water, they need to trap water underneath their shell in order to continue to respire. So they're usually going around and they're feeding when the tide comes up. So that home scar is what allows them to trap the water. It's generally assumed, the fact that they're intertidal, that they're avoiding predators, because whilst they're out of the water, even though they're not doing much themselves, other predators can't actually get at them, although there are things that still eat them. And they have a planktonic earlier phase of the life cycle. That's what allows them to disperse, because otherwise it would actually be quite slow. These things, once they're on a rock, they meander around and they have a memory, they come back to their scar, but they don't particularly do long-term tourism. They just sort of move in that particular rock. So their dispersal happens at an earlier stage. Interestingly, that sort of pink-colored picture on the bottom right is a picture of their radula. Now, this is actually the inspiration for the alien's teeth in the Aliens movie. What they've actually found now is that it's also the strongest known biological material, so it beats spiders' webs. Right? And this is because these things literally scrape the rock in order to ingest the algae that's actually on it. So, and there's a lot of work currently being done on those. And like I said, and that's what I've been doing with a lot of my time, actually going down to the shore and looking at these things. So, but you can, like I said, you can do lots of interesting work with them. There's a couple of limpets having a tussle. I know it's not usually, but there they are. Sometimes they do interact quite aggressively. It takes a long time, but they do it. And via a long and tortuous road, I got interested in this particular species, and I've done quite a bit of work with Jerry too, who's here, Patella fruginea. It's interesting because it's actually the most strictly protected marine invertebrate in the EU's Habitats Directive, and it actually is worth studying because, apart from the fact that some of them can be quite beautiful, as that one is, it's not just can we save it, but the questions of why it ended up becoming, coming to that particular point. So, I was also lucky to work with colleagues in the University of Seville, for example, and we managed to see how they change from male into female and at what sizes, and the fact that, for example, the females are literally only the largest ones, and every single centimeter that they grow, the actual sort of number of eggs that they produce goes up by one order of magnitude, which is significant because, 3 centimeters may multiply the number of eggs you do by 1,000. Genetics, it's opened up a world of possibilities, really quite interesting work, and even how we, as a species, are actually impacting. Very quickly, it's very interesting to have a look at those images, but the clear evidence is that obviously where there's no people, you actually got far more females and therefore far better reproducing population. Because people take the big ones, whether to fish or to other places to eat, but the large ones are the first to go. But one thing that caught my attention, obviously, and this came from starting the museum, was actually this present-day distribution, very, very disjuncted in the Western Mediterranean, but very fragmented, very, very few. I know there's some large bits of red there, but sometimes we're talking about only a few individuals left. And yet, when we were lucky enough to either go to archaeological excavations elsewhere or see museum collections, this thing was everywhere. It's in all these collections. These things were, and these didn't come from archaeological excavations on shores. These came from archaeological excavations on places where people had been living. So people were actively collecting this. Why? It's actually the largest, or one of the largest limpets in the Mediterranean, and it also tends to live quite high up the shore, so it's easy to get at and gives you a nice little package of food. And so this was actually quite interesting, but if you start to explore the possible reasons for its regression, what you have a situation is, for example, this is something that come out of a standard textbook, and it says species isn't there because, and you're talking about distribution to limits, behavior, biotic factors, abiotic factors. Nowhere there is a historical factor. in that sort of like checklist. And they tend to be mentioned, but they're often ignored. And the reality is pretty much most of the ecological studies that we have are based on work which are very, very small, both in terms of scale and time. So we're extrapolating to global scenarios from what actually are very, very short, very, very small, either experiments or observational studies. And most of these work are less than half a century old, which means that we're actually looking at systems, etc., which are in all probability already highly impacted to start off with. So if we look at and we scale up, we can see that history, together with speciation, climate extinction, etc., operates at such large scales that they're usually not included in most studies. And in addition, very often the quality of the data are lacking, because what you have might be a shopping list from someone that went to a market with common names. You don't even know what those refer to. It starts to become complex. So it's easy just not to do it. But you can very quickly start, and this happened being in the museum, obviously, is starting to see how things were affected. So I'm going to go quickly through some of them, some historical examples as I take you back in time. An example of Ballenera, which is a whaling station across the bay. And that's a picture of it. This sustained a whaling industry that obviously needed to work in order to invest that time and effort. There was another one across the strait. It wasn't that this was the only one around. We'll come back to this one afterwards. So I'm just going to go through a few examples. For example, one of the things that caught my attention when I first arrived were these hundreds of large oysters which had been excavated in urban excavations, and if you had asked me as a marine biologist, do we have oyster beds here, I'd have said no. I've never seen them. If you had asked me to describe the marine ecosystems of Gibraltar, I wouldn't have included oysters ever. But then again, I was talking about my own personal experience. So the moment you start to dig back, literally, these things start to arrive. And you can start to see, I'm sure you might not be able to read that very well, but there are references to Gibraltar having oysters, people coming even in the British period, even though there weren't many, because this gentleman says they are scarce here but large. Nowadays they're actually described as a separate sort of like form, which is from deep water. They're in deep water because we have overfished the big ones in the shallows. This is the reality. This is one of the things that Clive was alluding to. We end up sometimes defining things on the basis of data which is already skewed, but we don't have the grounding to show it. And there's even 2 oystermen in the 1777 census, but by the mid-19th century, they disappear. If we go further back, Portillo, and the quote is in Spanish, but essentially he's saying that Gibraltar pretty much was supplying, in other words, the area of the Straits, was supplying pretty much the whole of the entirety of southern Spain with fish. If we consider bluefin, not red tuna, which is just a translation from the Spanish term atún rojo, but the bluefin tuna, Tunus thinus, that comes out in the media a lot. And we have some beautiful illustrations by the gentleman Anton van den Wingard, which is in the late 16th century. This is fishing taking place in the Barbate, Almadraba. And they're very, very accurate. In this particular case, it's accurate accounts of catches, and I'll come back to this one when I'm sort of tying threads at the end. As you go back in time, so in the area very close by, you have the Roman settlement of Bailo Claudia, and that was used to commercially exploit murexes for that purple dye, but it was also used, because they had almadrabas there, to actually get fish. And they used to do this to make the garum sauce, which was highly prized. And what's interesting here, and this I have to thank Arturo Morales, who allowed me to, is very happy for me to share this, is that as you go, as the Roman Empire, shall we say, or sort of like the Republic becomes the empire, progresses, what you find is that the type of fish that is being used gets smaller. So the tuna moved to mackerel, and the mackerel then move on to sardines. Now this is something which is known as fishing down the food web, and it tends to happen when your technology doesn't change. Because usually when your technology changes, and instead of having a fishing rod, you've got a boat with a huge net and a fish finder or whatever, then you all of a sudden can start to get more of the same. But if you're staying in the same place and doing the same thing, as you overexploit particular type of organism, then you tend to move on to the next thing that it usually would have been feeding on the food web, and you become the predator in lieu, and then you sort of travel down. Eventually, you end up with plankton that starts to become quite difficult to collect and eat. But the reality is, this is it. But it's very interesting that it's happening back then, because you would have thought there's plenty of stuff around, but at the very least, locally, there's evidence that we were over-exploiting the resources. So how far does this go back? This interaction with the sea, this exploitation with the sea. The first thing is that I'd mentioned that coastal environments are very, very productive. And for example, mussel beds exposed coast reach productivities which are equivalent to tropical rainforests. So it's actually very, very interesting. And within these habitats, I'm going to focus on the rock intertidal because it's what I know about and can talk about it, but it's readily accessible. It is biomass rich, much more so than sandy shores, and you can easily see, because the stuff isn't hidden, and you can collect the resources that are there. And it doesn't require any special technology or sort of or training or anything like that. Any member of your group can go down and collect the resources that are available there. It is, however, rather narrow, which is interesting because it comes back to this potential of overexploitation. It's not, and what actually varies how narrow it is, there's two things. One of them is the slope of the shore, and the other one is how big your tides are. So it comes back to the earlier thing we were talking about before. So it's been quite lucky because things that you do without realizing start to become relevant later. So we were lucky enough to work in what is now World Heritage site, the Gorham's Cave complex, and within Gorham's Cave, this is something we published a long time ago. Clive and Geraldine will recognize it in 2006, and the famous levels 1, 2, 3, and 4. But just to give you a quick background, well, you've got 4 levels very, very quickly. The level at the very top, level 1, is essentially ascribed to Phoenicians. Level 2 is Neolithic. Level 3, Upper Paleolithic, which are the first arrivals of what we would call anatomically modern humans, which are people like us. And the level 4 beneath that was ascribed to Neanderthals. All right. And the other thing is to say is that obviously, again, I was lucky to have studied what I'd done because marine mollusks have lots of hard shells and they fossilize easily and they preserve well, and there's far more evidence of them than there are, for example, of human skulls, even though human skulls are much nicer to find. But nevertheless, you can actually do some quantitative work with things like mollusks. And some interesting general trends emerge. Certainly, there are particular groups which are consistently targeted regardless of the period. There's also some organisms which are collected because they're pretty and you turn them into decorations. But that's again, that's worthy of another talk, because what you do with those are completely different. The reasons why you get them are completely different, and the amount that they travel is awesome. You'll find one of these things in the middle of the Siberian plains, and it's because it's been swapped from hand to hand to hand because it's an item of jewelry. You're not actually taking it to eat. So if we exclude those, I apologize for the graph, but if you look at very, very quickly at that, essentially what I did was I just correlated the proportions of the various species that were found in each level. So level 1 against level 2, level 1 against level 3, 1, 4, 3 versus 2, and 4 versus 3, etc. The correlations are strikingly and consistently positive, 0.98, 0.97, 0.99 throughout, with high significance. In other words, whether it was Neanderthals or Upper Paleolithic or Neolithic or Phoenicians, the signatures that are coming out in terms of the types and proportions of animals that we're finding are consistent. So people seem to be doing the same thing, regardless, at least for that period, exploiting the intertidal in similar ways. But there's one interesting bit about intertidal exploitation which happens For example, in the Mesolithic, which is linked to the Neolithic, and this is actually the this is actually the consumption, the sustained exploitation of marine mollusks, particularly in Cantabria and the Atlantic coastline of present-day Portugal, and you've got these huge middens of shells, yeah. And this is one of the things that I'll ask you a question, right? There in Cantabria, then Atlantic, there aren't any in the Mediterranean, and so people will say, well, okay, maybe the people that inhabited the Mediterranean coast hadn't figured out how to do this yet, or maybe there were cultural differences that stopped them from doing it. And one of the first things that I would say, well, I mean, usually Occam's razor tends to be best, and what you want to do, is there a more simple, straightforward explanation for why these things aren't there? And so this is stemming from the PhD studies I mentioned. You had that very interesting result that the tides were really important in conditioning what was there. And in fact, if we actually pick the two species that are most evident, which are mussels and limpets, and you can see how they increase in numbers into the Atlantic. If you look at the side of the curve, you'll notice that it's a logarithmic scale. In other words, if I just put the numbers with increasing distances between them, it would start incredibly small in the Mediterranean and become incredibly large. But if you just look, for example, in the Mediterranean, you'll see that there's limpets and mussels are in the 10s and 20s, whereas if you go into the Atlantic, limpets are in the hundreds and mussels are in the tens of thousands. Now this is per linear meter of shore. So if we then confirm, so we can actually get the tissues, we can actually see what the calorific contribution would be, and we can pass this over to the data that we have, and this would show us pretty much how much energetic contribution we're getting from each mussel or each limpet that we are eating, with a plus or minus, which is why you've got that little sort of like bar. And this is, like I said, per linear meter. It doesn't go into the additional nutrients that you get, etc., which some people had, considered to be something which can feed into increased cognition, etc., because there's lots of sort of trace minerals, etc., which are actually found to be quite good for brain development. Similar for limpets. So what we have is, quite interestingly, if we look at the coast, if you're in the Atlantic, you can live for 5 days, get enough energy to live for 5 days on one single linear meter of coastline. This much. You wouldn't have to move if you didn't want to. If you go to the Mediterranean, right, you'd have to walk half a kilometer of coastline to actually get the same amount of energetic return, which doesn't take into account the fact that you use up a lot more energy moving down than having to sit down and just eat. So in other words, it's more expensive to do it in the Med. So why aren't there shell middens in the Med? Because you aren't anywhere on the coast long enough to make one. There's not enough stuff around. You don't need to invoke cultural differences or sort of people not thinking the same way. The resource just isn't there. And obviously, when the resource isn't there, then you end up with issues of invisibility, and we end up saying, well, if it's not there, it's because they didn't know how to do it. No, it's just that the data are very, very sort of low level. So this was followed by work which explicitly compared then the modern humans and the Neanderthals with regard to their exploitation of these same marine mollusks coming from Gorham's Cave. So this is a table, and essentially what we did in order to weight adequately the contributions of each of the periods, what we compared were proportions. And if you compare the proportions of the intertidal mollusks, which are highlighted there, and in fact, before I change, there's been recent quite extensive media coverage about the fact that they found that Neanderthals were sort of like diving to get stuff because they found that they were having, marine mollusks which are subtidal. These were already in that same list way back in 2016. But I suppose it's how you market yourself. But so if you compare the Neanderthals versus the moderns, it's a straight line. And I'll put pictures there so you can see what types of animals we're talking about. There's no statistically significant difference between them. Both of them were pretty much doing the same. Why is this important? The importance stemmed because the fact that I talked before between the Phoenicians and the Neolithic, no difference between the Neolithic and Upper Paleolithic, but we're always talking about people like us. And even though now we know that we are also part Neanderthals, and Neanderthals are pretty much people like us, back then there was certainly a big division between people like us and Neanderthals were considered to in many ways be inferior, less cognitively complex, etc., etc. So showing that moderns and Neanderthals were doing the same was actually quite a big deal at the time. Why did this come about? Well, one of the reasons this came about is because for a long time, this mantra of reduced sort of cognitive capacity, and that's by the Neanderthals, and that's obviously why we killed them off, is because when you looked at archaeological excavation, relatively, so-called more recently, in Mesolithic, there'd be a lot of evidence of this marine exploitation, including those shell middens. But you get to the Upper Pal, there'd still be quite a bit, with a little bit of mixture of sort of like terrestrial. But in the Middle Paleolithic, when Neanderthals are around, is pretty much almost exclusively, or very, very little evidence of engagement with the sea. So the systematic and sustained exploitation of the sea was done by us because we were cleverer. We realized that this was a useful resource. The Neanderthals, even though they had them in front of them, weren't clever enough to really, take advantage of the situation. Could this come about by other extraneous factors? One asked ourselves, and Geraldine was talking about this yesterday. We were talking about the ice ages, and what we have is a situation where a lot of the water inland has now been converted into ice. Over the last 2 million years, one of the constants has been, the Pleistocene have been these ice ages. These ice ages tend to sort of like cycle over about 130,000 year cycle. And this top graph shows a global climate history. You can find them. There's a lot of them around. A lot of them are based on the GRIP Iceland core. But we're interested in the last 125,000 years. So it's that bit there where it says warm and cold. And it's interesting to note, because the graph below, this is the sea level. And what's really interesting is that it's interesting to note how closely sea level mirrors the temperature. So the last time temperature was the same as it was today, approximately about 125,000 years ago, and sea level was pretty much at the same time. And as the temperature goes down, in sort of almost like, it's a punctuated decrease over time. It's going up and down, but it's slowly going down. So from about 125 to about 20,000 years ago, temperatures are getting colder and colder and colder till you get to the last glacial maximum about 20,000 years ago. And then there's a relatively sharp increase in temperatures and a relatively equivalent sharp increase in sea level. What does that tell us? During this period that we're looking at, and when the Neanderthals were living in Gorham's Cave, etc., it was colder, but sea levels were also lower. And if sea levels were lower, then, and you will have known this one because I've used it before, but if this is what we see when you look out of Gorham's Cave, nowadays, this is just a superimposition, this is what the Neanderthals, or something like that, is what they would have seen. This means that just nipping down to get a couple of mussels and limpets for lunch is not a 10-minute job. So what you have is a fact that that resource, that thin band of resource that you have to go to, is significantly a good distance away. And if you are going to do it, chances are you're going to consume them where you're at. And you might bring a few back for Granny who's in the cave and can't go out for you, but it's not going to be something you necessarily bring back and is going to be back in large amounts. So that evidence is going to tail off. So for example, what you have is, if this is the strait, and we drop the sea level by about 120 meters, which is about as far down as it goes. And you can see those islands that pop up that I mentioned, etc., and the straits getting narrower and all of that. But if Neanderthals had been exploiting stuff along the shoreline and leaving most of it around the shoreline when they consumed it, and then going into the hinterland and maybe hunting animals and leaving evidences of that, then if once the sea level comes back up again, that evidence of that exploitation is now underwater and probably lost. And when people like us come to a present-day shore and they leave evidences of their collecting of marine stuff, you end up with the pattern where there appears that the Neanderthals were only exploiting terrestrial resources. So it's a very neat way of actually exploring that and explaining why you get that. The evidence is underwater, that's another story. But this obviously kick-started a range once we knew where to look, so results started to come in from Vanguard Cave, for example, and also other types of marine organisms, fish, monk seals, we've got tunas, fish obviously, crabs, sea urchins, so all of these things are coming through. But then sort of people will sort of say, well, yeah, but in Gibraltar really, these Neanderthals were just sort of dipping in occasionally. It wasn't systematic. The moderns were systematic. They were doing it all the time. And it's always an attempt to continuously create this almost them and us. We were doing these things differently. And so the implication is that it's a numbers game. And the reality is this, that if we do look at the numbers, because of the reason I told you before, the proportions might be comparable, but the numbers in the Neanderthal levels are quite a bit lower. And in order to talk a bit more about this, I'm going to take a little bit of a detour, but it's still an interesting one because it's still linked to answering these questions, and it still has to do with limpets. So I'm still carrying on with limpets here. So I'm going to talk a little bit about oxygen isotopes and climate, and essentially without going into too much detail, this is work we did with Julie Ferguson and Gideon Henderson, I believe, from Oxford University at the time, with the rest of our team here at the museum. And oxygen isotopes can be used to calculate many things. One of the things is temperature of the sea, fundamentally because there's more evaporation of the lighter ones in the summer, so in the summer there's more heavy isotopes in the water, and vice versa in winter. Right? So if you can actually get a handle on those, and this is what you actually use, for example, in the ice core data, you actually look at the oxygen isotopes, and that's what allows you to get a handle on the sea temperature. But the question was, would animals also trap those isotopes in their bodies in some way and allow us to look at these temperatures? And obviously a good candidate was things like limpets, because they are well represented in archaeological records. Their shells actually are really quite robust, so they tend to stay entire and complete. And they do grow periodically by adding successive sort of layers of calcite. So what we do is we get the shells, cut them down the middle, and drill them at locations. So from the oldest shell growth, which is at the apex, all the way to the edge. And the theory would say that if the heavier or lighter isotopes were incorporated, I keep hitting this microphone, sorry, were incorporated into the shell, then we could use these to actually measure the sea surface temperature. And so that was the theory. And we did that. We collected a number of limpets, and Julie cut them up and drilled them, etc., and did all the oxygen isotope work. And when we compared it to satellite temperature data, sea surface temperature data, that's what we got. It was really, really great. These were a couple of limpets I just collected around the eastern side, and they were telling us pretty much what the satellites were telling us that the sea surface temperature was. So having done that, the next step obviously is to grab a couple of limpets which were significantly old and see what that gave us. And look, lo and behold, we could actually see what the temperature was in this particular case 24,500 years ago, give or take a few hundred years, in summer and in winter and in the intervening periods. Which is really, really quite neat. And this is a wonderful archive which, is still there to be sort of exploited. And that was published. I said, as Geraldine alluded to it yesterday, it was very interesting because we actually got limpets from different periods, and we could actually show that there was, this greater degree of seasonality. It was during the glacial periods, and also the effects of the Heinrich events, etc. But why is it, this is not really relevant to our question on exploitation? Well, it is, because something which stemmed from that is obviously that if we have, and I come back to the same limpet I showed you before, and you got the distance along the shell from the edge, then the extreme left gives me the season when the limpet was collected. And if you actually look at that, and you actually look over time, going from the oldest ones and bringing it slowly closer and closer to our current, where we are now, what's evident, there's two things which are interesting. One of them is there seems to be a movement, a trend from what seems to be exclusively winter collecting towards more of a spring collecting, but this is from almost 40,000 years ago to 20,000 years, so a 20,000 year time period as the temperature was getting progressively colder. And when the Neanderthals go and the moderns come in, the moderns are collecting it at the same time of year. Now we can go into why they're collecting it, but certainly they aren't randomly coming across and just getting them as and when. They're actually coming down, I would argue, systematically in a particular time of year to collect and exploit the intertidal land. So it was actually really, really quite interesting. But the low numbers are still a problem. So another thing that obviously that we're looking at, and I've sort of continued to look at, is that based on data from others, it's, the hypothesis is that there would be this sort of like, there'd be the relationship between the evidence of exploitation and the distance from the shore, taken into other accounts, such as sort of like, how rough, how difficult it is to get to the shore, come back, the heterogeneity, other things like that, could actually be modeled as a decay curve. So essentially you'd have a lot close to the shore and it would decay as you traveled inland. The inland would be curtailed by usually how long it would take for that food to spoil. So it makes sense in terms of logic. And the thinking is, if we can establish possibly where veil lines are, in other words, is the shape the same further back in time when the Neanderthals were there? Now we know that the front bit of the curve is going, but maybe the tail might still be there if you look for it. Yeah, the other part of the curve is now underwater, you can't exploit it. But if you can find the tail and you can maybe compare tails, if you want to say that, maybe we can get a handle on how these things were being exploited. Certainly if we put the Gorham's data into this model, it works. But that's just 2 data points. So I started to collect data from a whole range of sites around Iberia, and this is still a work in progress. So literally I did this, it's like I said, it's still progressing, but I did explore what shape of distribution came out from the Cantabrian area, because there's a lot of data from the north of Spain. And these initial results, because I did them yesterday, is really, really neat, because I wasn't expecting, but that comes out very, very nicely out of an R-squared of 90%, which is very, very high. And it fit. The data seems to validate the model. So now we're going to see how that changes from different parts. So it's an ongoing thing. One of the reasons I'm saying is that this is something that you get into and you just sort of like unpicking the threads, and it's interesting and time just flies. But it's wonderful to be able to explore these things and find out more about the world. So now I'm taking you, let's come back out from prehistory, because I suppose the outlying message here is that people have exploited. There's no overall evidence really for people to have sort of like sat down and thought about, and maybe we'll do this time and we're not going to do it, or we're going to plan better, or we're going to eat more vegetables and less protein or whatever. People exploited, and then and they exploited until either what they were exploiting couldn't support them anymore, in which case they did something else, or they moved somewhere else. And this was fine as long as there weren't many people. And you can see evidence in history of this happening again and again. If I could bring you back on a time machine on our way back, and I showed you that picture of the Almadrava, But if you have a look at that report, in 1 year, so that's between 1921 and 1922, you have the better part of 650 whales being taken by that single whaling station. And as I mentioned, there were others in the area of the Straits. Yeah? That's the figure. If we have Smith Dorian, governor of Gibraltar, got taken out whaling, and he said he had a whale of a time, excuse the pun, and 4 or 5 whales a day. People get really excited, and I get WhatsApp pinging when 2 whales are seen, and it's like, wow, and everyone's running around. And part of this, and part of, I suppose, as you move along, is like, is rather sad, is the realization that we live in a world that is increasingly more and more impoverished. And it's a world where we go wow at stuff that would have been considered to have been, really, really very, very poor in times past. And we fish a fish which we consider to be a real prize, and it would have been thrown back, and so on and so forth. I'll give you another example. Why is this man showing you a bluefin tuna catch graph? This is the Western Atlantic bluefin tuna population, and it's a graph which actually shows that, as fishing effort has increased, the actual population has actually dropped now down below sustainable levels, which is bad enough in of itself. But let's go back to those lovely images of Wingard. I love these because this man was drawing in detail, and he's talking about, El Virador de la Mar, El Capo. He shows how, these didn't have fish finders and stuff like that. These people were going out in rowing boats, encircling the tuna, bringing them into the shore. Then they were hooking them. You can see them with the hooks, and a couple of them on horses, sort of essentially beating. And then these fish were being dragged up, and they were being hung up to dry, possibly salted, etc. In one single summer, in 1575, over 85,000 tuna were collected, most of them averaging around 400 kilos each. Everyone now flips out when it's 200. Wow, it's really big. Which is why I smile when all my friends tell me there's more tuna now than ever before. But you can understand why they say it. And if I go back to the graph, that line is the number of tuna that were collected back then. It's about, good 4 times more than the remaining Western Atlantic tuna population. And that graph finishes in 1990, so I suspect it hasn't gotten much better. And as we do this, what we are doing is changing those ecosystems. And if you don't know how much effort it took to fish 100 years ago, then you don't realize that the effort you're putting in now in terms of resources, time, and etc., is significant. Absolutely. Technology is the thing that keeps on allowing you to extend that carrying capacity. Just to mention briefly, we've lost our seagrass meadows, critical habitats. We've tried to restore them. We've tried, there have been a few efforts, but they haven't been successful. We've tried similarly with oysters. But the point of me saying is whether we are successful or not, these aren't impossibles, but increasingly the time and resources needed in order to try and get these things to any semblance of what they had is growing. So the pressure tends to be to patch it up rather than put it back. And this is self-evident. This work I did with Geraldine, we actually managed to find ways of moving this endangered limpet without it dying, or at least pretty much almost none of them dying, which was really great and welcomed. But why is it welcomed? Because people want to continue to develop ports and marinas, and this thing is actually inconvenient. And part of it, I suppose, and one reason I want to mention is Daniel Pauly, who came up with this thing called the shifting baseline syndrome, and it's very interesting. But essentially, he says we're transforming the world, but we don't remember it. And people accept this because they don't know what was there. This historical component is missing very often when we talk about conservation, need for conservation, etc. But it's come out in the talks. I mean, Leslie was talking about it the other day. Tyson was, almost everyone has mentioned how there have been significant declines in what we have. But the emphasis then tends to go into, well, we have to look after what we have and what can we do to do it, etc., etc. But we are good at forgetting. And one of the, usually the shift in baseline syndrome tends to be ascribed to almost like intergenerational. You don't remember what your grandfather used to fish because obviously you didn't fish when, or maybe, you were only a small child, but as the generations pass by, you forget. But as I mentioned before, including myself, quite a few speakers have noticed this decline within our own lifetime. This is not now that a generation forgets the previous generation. This is like, we know what's happened, but for most of us, there's actually a little bit of, selective memory adjustment and saying, well, this thing will eventually work itself out and it'll sort of, it'll be okay. And I'm not talking about the people in this room because I know we're all passionate about this, but ultimately we have to carry all of society with us and things like this, and this is, I think, where the challenge lies. And we're looking at, and some people have talked about restoration and rewilding, we really need to have a very good idea of that historical trajectory of the system that's concerned. Because otherwise we could even be affecting what we decide to keep based on what we consider to be worthy of restoring, and these kind of things can be very subjective in of themselves. So for the future, I mean, these are a number of elements that have been identified as essentially being outcomes of human expansion that in of themselves lead to altered ecosystems. And the whole thing is a cycle. There's a great article, you want to have a look at it, 2001 article, it's almost 20 years now, by Jackson et al. in Science. But they showed how ecosystems really became far more impoverished with following human impact. But the interesting thing about a lot of this is that, and it's a wonderful quote because John Steinbeck talks about it in his Canary Row, which is one of my favorite books. But he wasn't an ecologist, but his friend Ed Ricketts was, and he was a marine biologist in the California shoreline. We said it isn't true that what's disturbed comes back. The disturbed balance often gives a new species ascendancy and destroys forever the old relationship. And this is quite interesting. This has been seen before. Just letting nature to fix itself won't happen. He was using the example of the upper rock when we're talking about the garrigue, also before yourself, Leslie, etc. You now have to actively manage. Sort of like benign neglect is not a solution anymore. Because you've removed the predators that were keeping the balance, and you've removed, so you actively have to participate. So can we restore old ecosystems? I think, reverting to an exact prior state is possibly almost like trying to rebreed the aurochs. This is going to be pretty much not really a possibility, but we can try and keep them as healthy and as stable and as diverse as possible. The world's in a state of continuous change after all, but the rate of change is dramatically high. So active management is what's needed, because the important thing to remember is, whether we like it or not, we need these ecosystems for our own survival, in many cases in ways that we still haven't figured out yet, and which is why we need to be sure that we keep them. But sadly, to be quite honest, as a personal viewpoint, I think our response, despite a lot of people in this room, is still lacking. I thought that was a very interesting cartoon with regard to how we prioritize on immediate things and perhaps aren't seeing there's a huge tsunami which is coming our way. And without further ado, thank you all very much.
Thank you very much. That was an excellent presentation, Darren, with a whole range of very interesting concepts and
in time.
Points for discussion, which I'm sure we will have now. So, Clive Finlayson.
Thanks, Darren. That was great. I'm going to be maybe atypically or maybe typically provocative. And going back to what I would call, certainly when applying it to prehistory, this myth which we romanticize and that we call sustainability.
Yes.
I don't think that people at any point as hunter-gatherers ever thought that they were being sustainable.
Absolutely.
They just woke up every day, exploited what there was, and moved on if they could or didn't. And that's what we've always done.
Yes.
Now, there may be factors such as density dependence that affect all organisms that can control population sizes. So I don't think that the way, other than factors to do with technology that makes it worse, are ways of exploiting the environment are any different than they were then. The only difference is that there's billions of us now, and there were very few people then, so the actual observable impact on the environment was different. Would you care to comment?
Thank you very much. Yes, I can't agree more. I mean, the reality is people, I think what comes out is people have exploited until either ecosystem or population collapse, like maybe it happened in Easter Island, or like I said, they moved elsewhere. And as long as the numbers of people are significantly less than the resource that you're exploiting, then it's okay. But this is the problem, and obviously technology and culture has allowed you to adapt to particular situations, but very often when you end up is with monocultures instead, like farming, etc. But up until now, there was always somewhere else to go. You go out for some tapas, and instead of octopus, you get pota, and you say, well, it's not the same, but you still eat it. This has been fished somewhere off the coast of South Africa and brought all the way here for you to enjoy it because there's not enough octopuses in the sea around where you are now. But you shrug it off, and people will continue to exploit. As you quite rightly say, there were fewer enough of us. My professor at Southampton was an expert in pollution. His saying was always, the solution to pollution is dilution. And what he was saying is, you can't get rid of the stuff, but if you can sort of bring it down to low enough levels, then it really goes under the radar. It's not doing enough damage. And that's pretty much what almost any organism in the world is doing. It's just surviving, exploiting and doing the best it can. And as long as the numbers are pretty much in balance, then you're not doing that much damage. And as you've quite rightly alluded, we should be hitting 10 billion relatively soon. This is really at the bottom of these debates, and unfortunately something which tends not to be tackled. We talk about the need to eat more vegetables, we talk about other stuff, but we don't actually say there's too many people. We are, it's not something which is a popular thing to say, but the reality is, but we should have, one would argue, enough cognitive capacity to realize what we're doing wrong. Now, whether or not we want to do what needs to be done in order to save ourselves, because that's really what it is, then that is a different matter altogether. But up until now, we've just acted as smart monkeys. That's pretty much it.
Let's face it, the evidence is not very encouraging.
No, not at all.
Further questions or comments from the floor? Just a quick one, Darren. Is the work on the limpets and that you showed in order to determine temperatures and so on still ongoing? Or is that something that you may expand to other species as well?
It has been expanded to other species. There's been work done, particularly flipped it on its head. Rather than establish temperatures, they were using it to establish seasonality of collection. So they were only measuring on the edges of the shell. But it's been done for top shells, for monodontas, gibulas and monodontas in other parts of the world. Also been done for mussels, I do believe. But certainly most of the ones which have strong shells and have managed to keep are usually the limpets and the top shells. And there seems to be a consistency for coming to the shore at or around sort of like winter.
Across all taxa that you've looked at?
Yeah, pretty much.
Okay, that's interesting. Any other questions or comments?
Yeah, so just to what people are surmising that maybe is linked to some sort of a larger cyclical activity. In other words, you go down to the shore this time of the year, usually when it's colder, because when it's warmer, what would happen is the snow would probably, or the cold would probably stop you accessing, for example, ecosystems and habitats which are, for example, higher up mountainsides, etc. So in the summer, the ice would melt, it would allow you to be able to move up and exploit those. And then in the winter, you come back down to the shore where you're more buffered temperature-wise, and you have these resources on the shore. So essentially, it's resource tracking. It's a small-scale version of what Clive's birds are doing on a large scale when they go to Africa.
What's interesting as well is because marine species are available all the time, and your ability for collecting them, or the seasonality, inverted commas, for collection is based to a large degree, as you've said, on weather. But if you extended that to land mollusks, where the situations may not be exactly the same, different factors, such as estivation, when snails are sometimes collected more on land than during other periods, may highlight different strategies of collection. Is that something that I know we've spoken about it in the past, I'm just trying to raise it to me, but it is something that
there's a whole range of possibilities.
A
lot of these species tend to, for example, develop their eggs, for example, I know limpets do in winter, so the fat content would be higher. So even though you're not actively measuring their fat, but they may be tastier, because fat tends to be quite nice. So therefore, that time of the year, they may be tastier. So that's the time of year to actually go and get them. So there might be other reasons. There's much greater possibility of getting, toxic poisoning from a dinoflagellate thing in the summer. So therefore, you would not eat sort of mussels during the summer. So there's a whole bunch of possible reasons why this time of the year was selected, and there's certainly lots of areas to be able to carry out good research in. So we'll talk about this a bit more.
Excellent. Any further questions or comments from anybody? Well, thank you very much, Darren. That was very interesting, and it highlighted a lot of very, very important research work that's been done here in collaboration with other universities and so on. So that's excellent. Thank you very much.